dev vlog where we talk about the development of our newest game, Tunnel. I'm your host, Noah Rosenfield, and today's episode we're going to be looking at the prototype and sort of just running through how we built it and the problems and challenges that we tackled during that building, and also the challenges that we're going to be facing moving from that prototype to something that's a little bit better and has a little more. So let's just jump right into the project. Um, so here is our basic layout. You can see this is all just in a single scene for our prototype. Not a whole lot going on in here. We've got our camera, we've got a container for our level, and we've got our player object. We also have a canvas for this overlay stuff. We're not going to talk too much about that. We're going to stick to strictly the gameplay and less of the the UI elements and feedback that were the debug lines and things. Jumping into our level. So one of the things that we needed to figure out was how are we going to draw the tunnel that the player is making? And the way that we decided to approach this is we want to leverage the in-game collision systems, like the physics system that Unity offers. And so we figured, all right, well, in order to do that, we need to have many little objects that represent the terrain that we'll be able to collide with and then turn off as the player's shield hits those objects. So you can see what we actually have to begin with, just one giant block, one giant level block where we can define the size of this level cube. And then we convert this giant block into a bunch of smaller blocks so that, rather than colliding with one giant thing, we can actually collide with all these little things, carve out that pathway. So the scale, actually, we have this set up so that the scale of this object, it will convert, however big or small we make it, it will convert that entire thing into a bunch of one by one. And you can see we've just got a level cube prefab. This is just a little game object that represents a single cube in this whole space. And we run through the width and height of that large object, replacing one by one with a bunch of level cube tabs. And then the second thing that we needed to do for that was to pepper it with mines and shields, right? In order to have things for the players to avoid and to aim to pick up, we wanted to get that in there as well. Now, we certainly didn't want to have to lay these things out by hand. For an infinite runner of this kind of style, we really want to be able to, at least to start, work with some procedural generation so that we're not having to try to design a level yet. We really need to see if this is even fun enough to be worth taking the time to design a level around. And so the way that we did this, actually, I took an idea that I'd come across in reading Spelunky by Derek Yu, where he talks about his monster generation and how the simple solution is oftentimes the best solution. And so all we have here is if we think about this in terms of rows and columns, since we're converting this big block into a grid of rows and columns of little blocks, essentially, and we know the player is going to be moving through this grid, right? So through every row, one at a time, we just have an idea of what's the probability that there should be a shield in a given row or a mine in a given row. And so you can see we just are using some float values here to set a 1% and 10% chance by default. These are public values, so they're exposed in the inspector so that we're able to actually tweak these within the gameplay itself. And you can see here, we're just generating a random number, comparing it to that chance of whether or not it's a shield. And if these probabilities line up, then it goes ahead and populates either a shield cube prefab or a mine cube prefab in place of that level cube. And that's pretty much it in terms of how we go from this one giant block to a bunch of little blocks and adding in the mines and shields. So next, we've got the player. The player, we know that they are going to have this shield system where every cube that the shield comes into contact with needs to do a little bit of damage, or maybe a lot of bit of damage in the case of a mine, reduce the size of that shield until it goes down to 0, at which point we are going to trigger a game. So we're again leveraging that built-in physics system here. We have a sphere collider. And let me jump in a little closer to our player. There we are. Camera view a bit. There we are. So we have a sphere collider on our shield, and here it is. And our radius is set to a 0.5. So now the sphere collider, right? If you set this to a radius of 1, this is actually a percentage basis of the parent game object. So at 50% radius, that means it will be fully scaled to the parent game object, which is our player. Sorry, here we are, which is the game object itself. By parent, I mean the game object that's holding the component. So the scale of this object actually will control the entire scale of our shield hider. So beyond that, after we've got the physics in place so that we're going to be able to determine when the shield is interacting with each one of these level cubes, and then make an adjustment to the size of the shield based off of the damage value that's been assigned to those prefabs. The next thing we do is the movement. So with this, we knew that we wanted the player movement to be mostly automated. The one thing the player should be doing is controlling the boost to shoot it forward. And the left and right and the forward motion, that should all be automated. So what we're doing is we're actually, rather than using the physics forces and applying forces to the player's ship, we decided that what we wanted to do was to have a little more kind of fine-grained control over what kind of a shape this thing is going to be making. And we felt like that was going to be easiest to do if we actually manually updated the position of the ship in each frame. And since we know that we want this snaking thing, essentially we just use a sine wave. And so we check at what point in the sine wave are we, and we update the player's ship position to match that position in the sine wave. Take a look at that here. Yep, so you can see we've got a time in period, and we've got a few different things that we're exposing. The displacement, which is how far left and right the ship should move. Period in milliseconds, how long should it take for the ship to go from left to right and back again? And the units, the y units per period. So that's going to determine, is this a very tight S curve, like this, or is this a much looser, longer curve? And then lastly, the y units per boost. So when the player is boosting, how much should they jump forward before they have a chance to to start moving left and right again? And so yeah, we're just checking that in our update function. We again are looking at how much time has elapsed since the last frame, and what does that mean in terms of where are we in our sine wave? And then we update the position of the ship appropriately. And then, of course, here's our on boost function, which is tied to any input through the new Unity input system and an action map. And that gets us to a player that will be automatically moving left and right. We can boost them. The shield will collide with all these little cubes and change its size based off of the damage values for each of those prefabs. And next we'll look at the things that we can tweak in this, right? So we wanted to be able to figure out, we weren't sure how big should the player be in relation to the size of the level? How fast should the player move? And how fast should the player move, like horizontally as well as vertically? And so you can see, we use a lot of public values exposed in the inspector so that we're able to tweak these things on the fly. Oh, and here you go. You can see I've run the project. Here is that conversion of the giant plane into a huge number of individual squares. And the player object, okay, so you can actually see we've already made a few modifications, like the period in milliseconds. We boosted that up to 3. And we can go ahead, we'll go over here. This is what it looks like by default, right? So this is the gameplay you've already seen. You'll see if I boost up this period or if I lower the period, now we're going way faster than before. And go ahead and in order to actually run this little bit quicker or be able to show you a little better, other thing that we had exposed on the level was the chance for a shield and a mine in the line. So what I'm going to go is I'm going to go ahead and restart this. I'm going to drop this down to 0. So now there's a 0% chance that it's going to generate anything other than our default level cube. That should allow our simulation to run a little longer since we won't run into those. So we'll jump back into here, start it up again. And here we are back. Okay, we'll close that. Back to the player. Um, oh, wrong button. Apologies. Start this up again. Start our run. And so, yeah, you can see the displacement, right? If we want to have a little, much shorter curve there, if we want to boost up how many pixels per period we're going to move vertically. And on the boost right now, I can run this again, reset level. See, that's a 50 pixel boost, right? And if we want to make that really big, boost up to 400, right? Player goes really zooming forward. So we got to kind of figure out, how long, based off of also the boost millisecond timeout, how quickly are they going to move through that 400 pixel vertical change? And so these are kind of the values we've been playing with to try to figure out what makes the most sense in terms of, yeah, look at that boost. Crazy. And this one, right, if we, 100, oh yeah, really like we've actually done something to break it here. It's really, oh, I know why. Because it probably zoomed all the way down past the level. I'm going to guess that we are way below the bottom of the level right now. If I look at the scene, I think we probably have gone. See, where's the player at? Oh yeah, way down there. Okay, yeah, here we are. So way off screen at this point. See, here we go. Back to this. So the shortcomings of this approach, right? This is pretty good in terms of just getting us to something that we could play with, and that was really the goal. Was let's go from we have this, this idea of this model. We want to be able to at least like play with it and see how it feels, and it's not bad, right? It's reasonably entertaining. Um, the big shortcomings are the static references. In order to wire things up, especially towards the end of the prototype, towards the end of this development, with things like getting the UI to display, to have access to all of the data about the level, we kind of just started opening things up with static references and stuff like that. So obviously, for something that's needs to be easier to debug, we really want to be able to compartmentalize these each feature into its own thing, and so that's really what we're going to be doing moving forward. We have a level generation scene. I'm not going to save the change to the prototype. So we've got a level generation scene that will take care of just generating the level. There it is. And this is actually now saving out to, we're still doing that conversion to a bunch of planes, but instead of procedurally generating, we have taken a middle road where we procedurally generate into a scriptable object that can then be reused. So now, if we want to replay the same level again and again between play sessions, we have that flexibility. And we've also got our, our shield system is now compartmentalized to its own little test scene where if we run this and we move, have our player go and go, we're going to go and collide with this mine and boom, and then we're going to collide with the shield and boom, there we go. So just testing these interactions in this very limited environment. And then we're going to bring everything together back in a main scene and start to wire these things. And that's it. That's pretty much everything that it took to get this initial prototype running. You've seen where we're starting to go in terms of building out this system to give us a little more flexibility. And hopefully, the other thing we'd like to do is we want to be able to have changes be a little more universal. Right now, if I say, okay, I want the ship to be faster, well, what does that mean? Or if I want the gameplay to be faster, right now that requires a bunch of different tweaks, and you kind of, the values are very loosely related. So hopefully we'll have a system that's, maybe a little easier to conceptualize rather than having to toy with five different values to kind of make a stylistic or get a gameplay feel, right? We talk about moving faster. We want to be able to just have one knob that we turn and say, okay, this is faster. And then everything else that needs to change around that will kind of be related to that single control. And that'll help us tune things, I think, a little. But yeah, that's it. I hope you've enjoyed this episode of Tunnel Talk. If you have any questions about the development, anything that you've seen here today, please feel free to leave a comment. Reach out, let me know, and I'll do my best to answer any questions. So, thanks again for tuning in, and we'll see you next time. Peace.